Ever wondered how massive concrete piles are installed deep underground to support giant structures? Let's uncover this fascinating process. A CNC steel cage welding machine, also called a rebar cage welding machine, is designed to produce cylindrical steel reinforcement cages used in concrete foundations, columns, and pipes. Controlled by a programmable logic controller, it allows operators to precisely manage wire feeding, cage size, and welding speed. With CNC automation, the machine ensures uniform spacing, accurate dimensions, and consistent weld strength. It can produce cages in various diameters and lengths, and many models support automatic feeding, cutting, and welding. This reduces manual labor, enhances efficiency, and guarantees high-quality results, making it ideal for bridges, railways, and large construction projects. At the construction site, a large steel reinforcement cage is being installed to form the core of a reinforced concrete structure. This process is a critical stage in civil engineering works such as bridges, piers, and foundations, ensuring that the concrete element gains the necessary tensile strength and structural integrity. The operation requires precision, teamwork, and strict safety management. The cage, fabricated from D51 high-diameter reinforcing bars, is assembled in advance by welding and tying multiple layers of horizontal and vertical rebars. These bars are arranged in a grid pattern to resist both compressive and tensile stresses once the concrete is poured. Due to the large size and heavy weight of the cage, lifting is performed by a crawler crane equipped with a special spreader beam to maintain balance during hoisting. Before installation, workers carefully inspect the lifting gear and verify the alignment and dimensions of the cage. When everything is ready, the crane operator begins to lift the cage vertically from the ground. The cage is slowly raised and guided by workers using tag lines to prevent rotation and swaying. Coordination between the crane operator and the ground crew is essential for safety and accuracy. As the cage is lowered into position, workers stationed on the scaffolding or working platform guide it into the designated formwork or foundation hole. They ensure that the reinforcement is properly aligned with the anchors or dowels that connect it to the previous concrete section. Final positioning adjustments are made using measuring tools to maintain the specified cover distance between the rebar and the formwork surface. Once the cage is securely fixed in place, temporary supports or spacers are installed to maintain stability before concrete pouring. This careful installation process guarantees that the reinforced concrete structure will meet design specifications for strength, durability, and load-bearing performance. The entire operation exemplifies modern construction techniques combining heavy lifting equipment, skilled manpower, and precise engineering control to create safe and long-lasting infrastructure. The piling process is a fundamental technique in modern construction, used to create strong and watertight retaining walls or deep foundations capable of supporting heavy loads. One of the most efficient methods for this is the use of a temporary casing and hollow stem auger system. which allows piles to be installed with high precision even in challenging ground conditions such as loose soil or areas with a high water table. This method is commonly employed to form secant or contiguous piled walls, providing both structural strength and groundwater control. The process begins with drilling and casing installation. A hollow stem auger is inserted into the ground, surrounded by a temporary steel casing. Both are driven downward simultaneously using a twin rotary drive system, which rotates the auger and casing in opposite directions. This counter-rotation ensures stability, reduces soil disturbance, and facilitates efficient drilling. The auger is equipped with tungsten-tipped cutting teeth that enable it to penetrate a wide range of soils, from soft clay to dense gravel or weak rock. As drilling progresses, soil is brought to the surface through the hollow stem, creating a clean and stable borehole. Once the required depth is reached, the concrete pouring stage begins. While the auger is slowly withdrawn from the borehole, concrete is pumped through its hollow stem and discharged at the base of the hole. The continuous pumping of concrete ensures that no voids or weak spots form. As the auger is raised, the concrete rises upward, completely filling the space left behind. The combined motion of the auger withdrawal and the pressure of the flowing concrete guarantees a uniform and dense pile structure. This process also prevents the collapse of surrounding soil, even in unstable or water-bearing layers. After the bore is filled with fresh concrete, the next step involves reinforcement installation. A steel reinforcement cage is carefully lowered into the wet concrete while it remains fluid. The cage is positioned to the desired depth, ensuring that it is fully embedded and properly aligned. This reinforcement provides additional tensile strength to the pile, improving its load-bearing capacity and resistance to bending or lateral pressure. Following reinforcement placement, attention turns to casing removal. In most cases, the temporary casing is extracted once the reinforcement is in place and the concrete has gained enough initial strength to maintain its shape. As the casing is withdrawn, the surrounding concrete remains stable, leaving behind a finished reinforced concrete pile. However, in some conditions, such as when working in contaminated or highly permeable ground, the casing may be left in place permanently to serve as an additional structural or environmental barrier. For secant piled walls, the process is repeated with precise overlap. After the primary piles have hardened, secondary piles are drilled so that they cut into and interlock with the adjacent primary piles. This overlapping arrangement forms a continuous, watertight wall capable of withstanding earth and hydrostatic pressures. The high vertical accuracy of this method ensures that the wall alignment remains exact throughout the project, minimizing gaps or weak points. The system can be used in a wide range of soils, including those with a high water table, and can penetrate obstacles like existing structures. In conclusion, the piling process using a hollow stem auger and temporary casing is a versatile and reliable foundation technique. It combines mechanical precision with fluid concrete placement to achieve durable, high-quality piles. Whether used for deep foundations, retaining structures, or secant walls, this system provides excellent performance under a wide range of soil and groundwater conditions, ensuring stability, safety, and longevity for modern construction projects. The Stark JB80E hydraulic piling machine is a versatile and powerful piece of equipment designed for both piling and drilling operations. It is widely used in various construction projects and can adapt to harsh working conditions in all climates. Its quick change attachments make it suitable for multiple tasks, while its quiet and efficient operation allows it to perform effectively even in densely populated urban areas. The machine can be equipped with a range of tools, including a diesel hammer, hydraulic hammer, electric vibro hammer, vibrating hammer, and drilling rigs with different depths and diameters. These attachments enable the Stark JB80E to handle different types of foundation work with precision and speed. Key advantages of the Stark JB80E include excellent mobility, energy independence, high mechanization of processes, outstanding performance, and strong impact power. The rig's main structure is a robust steel frame mounted on a self-propelled chassis, allowing it to lift and position piles vertically. Under the hammer's striking force, piles are efficiently driven into the ground to form solid and durable foundations. The installation of large-diameter steel pipe piles, such as the 12.5-meter-long casing piles shown in the video, is carried out using several advanced methods depending on soil conditions and project requirements. The main techniques include hydraulic jacking, specialized drilling equipment, vibratory piling, and pipe driving. These approaches ensure both stability and precision during deep foundation work. In the impact method, the casing pipe advances along the borehole wall, or sometimes ahead of it if the soil permits. The pipe is driven to the required depth by successive impacts. When the pile length exceeds the standard casing section, additional pipe segments are welded or mechanically connected to extend it. This step-by-step process allows the pile to reach great depths while maintaining alignment and structural integrity. The rotary drilling method involves first excavating a guide hole equal to the length of one casing segment. The pipe is then installed, and the borehole is deepened using the rotary drilling technique. A new section of casing is inserted, and the process repeats until the desired depth is achieved. After installation, loose soil inside the casing is removed using the same drill bit. A Rebar is often used for this operation, allowing efficient pre-drilling. During drilling, the cutting wings of the bit expand outward to a predetermined diameter and retract automatically when the load is released, matching the pipe's inner diameter. Once the drilling tool is withdrawn, the excavated soil is discharged from behind the bit and pushed aside, leaving a clean and stable bore ready for concreting or reinforcement placement. This combination of precision drilling and pile driving ensures a durable and watertight foundation suitable for large-scale infrastructure. The accordion-type reinforcement cage, known in Japan as the Jabara pile cage, represents an advanced method designed to improve the efficiency and quality of cast-in-place pile construction. Traditionally, steel cages were assembled and tied at the construction site, which required large working areas, extensive labor, and precise alignment. The Jabara unit method solves these issues by converting the conventional fixed steel cage into a collapsible accordion-type structure that can be folded compactly for transport and storage. In this system, the steel reinforcement cage is prefabricated in a factory under controlled conditions. It is then folded into an accordion shape, allowing multiple cages to be delivered in a single truckload, saving both time and logistics costs. This folding process reduces material handling, prevents rebar bending damage, and contributes to the reduction of CO2 emissions by minimizing transport frequency. Once delivered, the folded cage is unfolded and restored at the construction site. Skilled workers carefully expand the cage to its designed cylindrical form, followed by the finishing process that ensures all rebars are properly aligned and securely connected, except for spacer installation. This efficient on-site restoration process maintains high accuracy and consistency, as most of the critical assembly work has already been done in the factory. After the cage is restored, vertical lifting or tatsuri operation is performed. Using cranes and lifting devices, the steel cage is vertically suspended and gently lowered into the drilled borehole. This stage requires precise coordination to keep the cage straight and prevent distortion. By applying the Jabara unit method, companies such as Fujimitsu Reinforcement Industry and Oda Ward have achieved outstanding results in labor saving, safety, and environmental sustainability. This innovative technique ensures high-quality pile foundations while reducing workload, site congestion, and carbon footprint, marking a significant step forward in Japan's modern foundation engineering. The Starke Piling Concrete Sheet Pile Machine is a modern hydraulic piling system designed and manufactured in China, widely used for driving precast concrete piles and sheet piles into the ground for various foundation and earth-retaining applications. This powerful equipment combines high-efficiency hydraulic technology, intelligent control, and a robust structural design to achieve fast, precise, and environmentally friendly pile installation. It is one of the most advanced piling machines in the Chinese construction equipment industry, representing the growing innovation and capability of Chinese heavy machinery manufacturing. Structurally, the Starke piling machine is built on a heavy-duty steel frame mounted on a crawler or steel platform to ensure stability during operation. The main working system consists of a hydraulic press head, vertical guiding columns, a power unit, and a control cabin. The hydraulic press head, driven by high-pressure cylinders, applies uniform vertical force to push concrete sheet piles or square piles smoothly into the ground without vibration. This non-impact method helps to minimize noise, reduce ground disturbance, and maintain pile integrity, an essential advantage when working in urban areas or near sensitive structures. The machine's power is supplied by a diesel engine or electric motor connected to a high-performance hydraulic pump. The hydraulic system features advanced proportional valves and sensors that allow operators to control pressing speed, pressure, and depth precisely. As a result, each pile can be installed with consistent force and alignment. The guiding columns are equipped with laser or optical positioning systems to ensure vertical accuracy, while the press head can automatically adjust its grip to accommodate different pile sizes, such as H-shaped piles, square concrete piles, or sheet piles. During operation, the machine first positions itself above the intended piling line. The operator uses the control panel or remote system to lift and align the concrete sheet pile between the guide columns. Once positioned, the hydraulic press head applies downward pressure, gradually inserting the pile into the ground layer by layer. If necessary, additional water jetting or pre-drilling can be used to assist penetration in hard or dense soils. The process is repeated continuously, forming a strong and stable foundation wall or retaining structure. One of the key strengths of the Starkey concrete sheet pile machine is its modular design and adaptability. The machine can be configured for various project requirements, including foundation piling for bridges, ports, retaining walls, flood protection structures, and urban underground works. Some models also support combination with vibratory hammers or auger drilling units for more complex soil conditions. The modular hydraulic clamps can be changed quickly to handle different pile profiles and dimensions, improving productivity on site. From a technological perspective, Stark machines integrate digital control systems and load monitoring functions. Real-time data on pressure, penetration rate, and soil resistance are displayed on the operator's screen, allowing immediate adjustments to maintain optimal performance and safety. The hydraulic system uses high-quality seals, precision machined valves, and reinforced hoses to ensure durability and minimize oil leakage. This makes the equipment reliable for long-term operation under harsh working environments. Compared with traditional diesel hammers or vibratory drivers, the Stark hydraulic piling machine offers many environmental and operational benefits. It operates with low noise, generates no impact vibration, and produces almost no exhaust smoke, making it ideal for projects in residential or ecologically sensitive areas. Furthermore, the hydraulic pressing method provides better control over pile alignment and prevents cracking or deformation of concrete piles, which is common with percussive systems. In terms of safety, the Starkey piling machine is equipped with overload protection, automatic shutdown in case of hydraulic failure, and safety fences around the operating zone. The operator's cabin features ergonomic seating, wide visibility, and easy-to-use joystick controls. Maintenance is simplified through centralized lubrication points, easy access panels, and onboard diagnostic systems. In conclusion, the Starkey Piling concrete sheet pile machine represents the integration of strength, precision, and sustainability in modern foundation engineering. Designed and produced in China with high standards of quality control, it provides contractors with a versatile and reliable solution for deep foundation and retaining wall construction. Its advanced hydraulic technology, intelligent operation, and low environmental impact make it a preferred choice for both domestic and international construction projects. The installation of the diaphragm wall involves the construction of 55 reinforced concrete panels, each ranging from 15 to 20 meters in depth and 600 millimeters in thickness. This retaining wall system serves as a crucial structural element for deep excavations, providing both earth and water retention. The process begins with setting out the panel positions and installing guide walls to ensure alignment and stability during excavation. A hydraulic grab or clamshell is then used to excavate the trench panel by panel under bentonite slurry, which supports the trench walls and prevents collapse. Once the required depth is reached, the excavation is cleaned to remove loose material and ensure a clean base for concreting. Next, prefabricated steel reinforcement cages are carefully lowered into the trench. Concrete is then placed using the tremie method, allowing the slurry to be displaced upward as the concrete fills the cavity. After the concrete hardens, the joints between adjacent panels are formed, creating a continuous underground wall. In addition, anchors are installed along approximately 60 linear meters of the wall to provide lateral support and enhance overall stability. This diaphragm wall system ensures the safety and durability of the excavation, forming a solid foundation for subsequent construction activities. The installation and adjustment of the Stark LH50B piling and drilling rig begin with preparing the working site to ensure a stable and level surface for safe machine operation. The rig is then transported to the site and carefully positioned using its crawler tracks. Once in place, the outriggers are deployed and leveled to provide additional stability. The hydraulic system is activated to extend the mast, and operators check the vertical alignment of the leader column using built-in leveling sensors and manual fine-tuning controls. Next, the hammer and drilling attachments are mounted on the mast. The hydraulic lines and electrical connections between the main body, power unit, and control cabin are inspected and tightened. The drilling tool or casing is positioned according to the pile layout plan. Calibration is carried out to align the mast precisely over the designated pile point. The operator adjusts the mast inclination to ensure it is perpendicular to the ground surface, typically within a tolerance of a few millimeters, verified by both sensors and manual measurement. Once alignment is confirmed, the rig's rotary drive and hammer functions are tested. The diesel engine is started, and the preheating system is used if temperatures are low. The hydraulic pumps are gradually engaged to check pressure stability. The mast height and hammer stroke are regulated based on pile type and soil condition, generally up to 15 to 20 meters in depth, with diameters ranging from 160 to 600 millimeters. Operators also adjust the clamp system to hold the casing or pile firmly without slippage. After all mechanical and hydraulic settings are verified, a test drilling or pile driving operation is performed. During this stage, parameters such as penetration rate, vibration, and hammer impact are monitored closely. Adjustments to hammer pressure or rotary torque are made to achieve optimal efficiency. The system is then rechecked for oil leaks, abnormal sounds, and proper functioning of safety switches. Finally, the rig is cleaned, the joints are re-lubricated, and all components are secured. The Starkey LH50B is now fully calibrated and ready for continuous operation, ensuring accurate pile installation and stable foundation performance under various ground conditions.